Hello everybody, in this video we are going to deal with friction on incline. Let's begin by reading the problem. A 62 kilogram person on skis is going down a hill sloped at 37 degrees. The coefficient of kinetic friction between the skis and the snow is 0.15. How fast is the skier going 5.0 seconds after starting from rest? As always, it's a good habit to write down what we know. The mass is 62 kilograms, the angle of the incline is 37 degrees, coefficient of kinetic friction is 0.15, and the change in time is 5.0 seconds. Lastly, the problem is asking for how fast a skier will be moving after 5 seconds, which is referring to the final velocity. We'll need to find the acceleration on the skier to find the final velocity, but even before that, the net force needs to be calculated. There are 3 forces acting on the skier: force of gravity, normal force, and kinetic friction force. The force of gravity can be calculated right away, but the other 2 forces aren't so obvious. To find the friction force, normal force is needed. However, this problem becomes slightly complicated because the normal force is not equal and opposite of force of gravity. So a creative approach is going to have to be used. Remember the x and y axis, x going left and right, and y going up and down. That's going to be changed a bit by tilting the x and y axes. The x-axis is going to run parallel to the slope, and the y-axis is going to run perpendicular to the slope. By tilting the axes, force of gravity actually points now in both the x and y direction, allowing it to have components fgx and fgy. Sure, gravity has components now, but we still need an angle to find those components. Let's draw this a bit more clearly. With force of gravity drawn like so, this shaded region can be seen as a right triangle. If the angle of the incline is 37 degrees, the other angle is 53 degrees. If you look closely at the y component of gravity, it makes a right angle with the incline. And if we know that the angle between FG and FGY is 37 degrees. Now we can go forward with the components. Calculate gravity first, which is 607.6 newtons. Based on the angle placement, cosine and sine will be used to find the y component and x component respectively, which comes out to be 365.66 newtons forward and 485.25 newtons down. Before moving on, let's make sense of these values. The y component of gravity keeps the skier on the ground, while the x component of gravity is what causes the skier to go downhill. Okay, so you might be wondering why we're going through all this trouble with tilting the axes to find components of gravity. The reason is now the normal force can be found, and the normal force is equal and opposite of the y component of gravity, 485.25 newtons up. With the normal force known, the kinetic friction force can be calculated by taking the normal force and multiplying it by the coefficient of kinetic friction, which comes out to be 72.79 newtons. With all the forces known, the net force can be calculated by combining the x component of gravity and kinetic friction force. The force of gravity is aimed down the hill, while friction is aimed up the hill, which results in a subtraction operation to find the net force. This comes out to be 292.87 newtons forward. Afterwards, using Newton's second law, acceleration is 4.72 meters per second squared. Lastly, to find the final velocity, a kinematic will have to be used. We know the time and acceleration, and since the skier is starting from rest, the initial velocity is 0 meters per second. Therefore, this kinematic equation would seem most appropriate. The final velocity of the skier after 5.0 seconds is 23.6 meters per second forward. Hope you found this video helpful, and thank you for watching.